So I just want to go over a couple of problems on solving quadratics day one. So this is numbers 2, 4, and 8 that I want to go over. So on number 2, they have x squared equals 44. And the way that you solve a quadratic equation, the way you undo a square is by taking the square root. So I'm going to take a square root of that side and the square root of that side. As soon as you are the one that's taking the square root, you have to say that your answer is plus or minus the square root of 44, because there will be two answers anytime you have an equation that has an x squared on it. Now, if they say to give you an estimate of the answer, it's okay to put this in your calculator and just do the square root of 44 that way. But if you don't want to take the estimate, then you're going to have to actually simplify that square root of 44. So the way you simplify the square root of 44 is you can go ahead and say it is the square root of 4 times the square root of 11. Again, still plus or minus, because 4 times 11 is 44. So this will be plus or minus 2 times the square root of 11. So that's one way to do it. If some of you like the birthday cake method to simplify radicals, then what you do is you'll take 44. You're going to divide this by the simplest or the lowest prime number you can think of, usually 2, 3, 5, 7, something like that. So if I divide this by 2, I'll get 22. I'm going to keep doing that again. I can divide it by 2, I get 11. I can divide by 11 and I get 1. The reason why they call it the birthday cake method is that this little one looks like it's a candle at the top of a birthday cake, and you know you're done when you have that one at the top. Next, what you do is you circle anything that you have 2 the same. So I have 2 2's. So I'm going to take that out of the radical just once as a 2. But this 11 here has no friends, so he has to stay underneath the radical by himself. So again, you can see that these two answers are the same, whether you prefer this way to simplify or this way to simplify. The next one I want to go over then is number 4. Number 4 says 5x squared equals 100. Before you can take the square root of both sides, you want to get that x squared term alone. So the first thing you're going to do is divide by 5. Get x squared equals 20. 100 divided by 5 is 20. And now you're going to say x equals, we can take the square root of both sides, so x equals plus or minus the square root of 20. Again, I can simplify that by saying that's the same thing as the square root of 4 times the square root of 5. I usually try and put the perfect square first because it helps keeps things lined up. And so I'll say that's plus or minus 2 times the square root of 5. And then the last one I want to go over is number 8. Now they have b minus 3 squared is 49. Well, this whole quantity is being squared. Think of it as kind of like one chunk of information. Like you can't break that apart. It's one chunk of information. So I can go ahead and just take the square root of both sides right now. And the square root of b minus 3 squared is simply b minus 3. Anytime you square and square root something, it's as if those two things kind of cancel each other out, and I'm left with b minus 3. So I have b minus 3, but now this is going to equal plus or minus 49, because again, if I'm the one taking the square root, I have to have a plus or minus here. So b minus 3 is going to equal plus or minus 7, because the square root of 49 is 7. So in essence, I now have two equations here. I have b minus 3 equals positive 7, or b minus 3 equals a negative 7. And I'm going to have to solve those two equations separately. So I can add 3 on both sides. And here I'm going to have b equals 10. Or I can add 3 to both sides here. And I'm going to have b equals negative 4. So here are my two answers for that equation. If you have questions, let me know.